Infinite limits and vertical asymptotes. So we're going to start off with a couple of definitions, and the first one is going to be limits from the left. And what we're interested in is if we approach a, x is approaching a from the negative side of f of x, if the function values, which are just the y values, grow without bound, that means they just keep getting bigger and bigger in either the positive or the negative sense as x approaches a from the left side, then this is how we write this. And we would say the limit is plus infinity or minus infinity. And then we could do the same thing but approach from the right side. So as in anything, it's easier to look at an example. So here's a couple of examples. I'm going to do them both with tables and with graphs. So here's our first function. F of x is equal to x minus 3 over x minus 2. And I'm interested in the limit as x approaches 2 from the negative side, which is the left side of 2. And so I keep picking x values that are closer and closer and closer to 2, but they're less than 2. And we notice that the y values keep getting bigger and bigger and bigger and bigger. They're growing without bound in the positive sense. Graphically, do you see here's 1.5, there's 3, 1.9, we're way off the charts, we're up here. So the closer we're getting to 2, the bigger these y values are. So in this case, we would say the answer is plus infinity, and we just write that as infinity. We don't write the plus sign. You can, you don't have to. Now if we look at x approaching 2 from the positive side, so this would be the positive side of 2, which means we're going to keep picking x values getting closer and closer to what, but we're on the right side. So 2.5, I get negative 1. 2.1, I get negative 9. 2.01, I get negative 99. 2.001, I get negative 999. So notice 2.5, negative 1. 2.9, negative 9. Do you see that the y values are growing without bound in the negative sense? So I would write this as this limit is negative infinity. So as a quick note, that technically the limit does not exist. But when the limit is growing without bound, we describe this with plus or minus infinity. So let's do another example. So here's our function f of x equals 3 minus 2x over 5 minus x. So this is the table, and we're approaching 5 from the negative side. We see the y values are getting more and more negative. And as we approach 5 from the positive side, our y values are getting bigger and bigger in the positive sense. So for this example, the limit as x approaches 5 from the negative is minus infinity, and the limit as x approaches 5 from the positive is plus infinity. So table, graph. So let me just do a quick one here where I'm going to do the whole thing from scratch. So this is going to be the limit of f of x equals 1 over x. So I'm going to do a quick table. And we want to approach 0 from the negative side. So really quick, I'm going to come over here. Here's 0. So we're coming from this side. So let me go 0.1. And when I plug in 0.1, I get minus 10. When I plug in minus 0.01, I get minus 100. Remember, 0.1 is 1/10. 1 over 1/10 is negative 10. Minus 0.001 is minus 1,000. So what's happening is this graph is doing this. So this answer here is negative infinity. And if we want to go from the positive side, that means I have to come from this side of 0. So let me go 0.1, 0.01, 0.001. And if I plug 1 over 0.1, I get 10. 1 over 0.01, I get 100. 1 over 0.001, I get 1,000. So the graph, oops, my picture's not the greatest. My graph is doing this. So this answer is plus infinity. So this is how you can find these limits, either by doing a table of values, what to look for, or a graph, what to look for. So now two-sided limits. So now if the function values grow without bound in either the positive or negative sense from both sides of a. So let's take a look at this graph. Do you see on the left side of -2 and the right side of -2, we get plus or minus infinity? So in this case, if I approach this function from the negative side, I get positive infinity. And as I approach 2 from the positive side, I also get infinity. Remember, that's this side. And that's the positive side. So in this case, since both sides are the same, I would then say the limit as x approaches 2 of f of x is also infinity. So if they are both going in this direction, it's positive infinity. Let's take a look at this graph. And if I do a quick table, I want to look at the limit as x approaches 0. And if I go from the negative side, so negative 0.5, I get -8. Negative 0.1, I get negative 200. Negative 0.01, I get minus 20,000. If I go positive 0.5, I get -8. By the way, do you notice here with the squared? Do you see if I have positive, sorry, this should be positive, not negative. If I have positive 0.5 or negative 0.5, when I square them, they give me the same thing. So do you see why it makes sense that if I plug negative 0.1 in, I square it? It's the same as plugging positive 0.1 in, squaring it. So I'm going to get negative 200. And 0.1, I'm going to get negative 20,000. So this one's graph is going like this from this side, and it's going like this from this side. So in this case, since both sides are negative infinity, then I say without a positive or negative is negative infinity. So in this example, they're both sides it's shooting up. In this example, both sides are shooting down. Now in that very first example, here's the graph in here. Notice from the left side I got positive infinity, from the right side I got negative infinity. So in this scenario, if I tried to approach 2 of this function without a positive or negative, I would say does not exist. This is because both sides are not the same type of infinity. And the last part in here is vertical asymptotes. We say x equals a is a vertical asymptote if the limit as x approaches a of this function is positive infinity or negative infinity. And it should be noted, it doesn't matter if we're looking at a left side, a right side, or both sides. In all scenarios, these would be considered vertical asymptotes. So, in this example, x equals 2 is a vertical asymptote. X equals 5 is a vertical asymptote. Funny word, isn't it? And in this case, x equals -2 is a vertical asymptote. So those are just 3 examples. Each one of these is a vertical asymptote. So this is just a definition of a vertical asymptote. This line, vertical line, x equals a, is a vertical asymptote if we approach either side and our y values are shooting off in the positive sense or the negative sense. And that's the end of this video.